Okay, so let's take a look at this circuitry that's inside these dummy batteries. Um, I mean, right off the bat, we see there's this big blob of probably a microcontroller or something really cheap though, and we also see this little current sense resistor, current shunt. It's a 50 milliohm resistor, so uh, it kind of makes sense that it would be monitoring the current um, drawn from the battery, maybe even doing some sort of overcurrent protection. Um, well, it might be doing. I'm not sure if it actually. If I mean, maybe the original ones do, but I'm not sure what this one does. And then we have this mysterious middle terminal here that seeing like the shunt resistor here is an indication that maybe the battery is talking to the camera via this middle pin, so something like a one-wire interface type thing. So yeah, I mean it would seem, you'd think that would be the case, because why else would you have that shunt resistor in there? Why would you have the little micro in here? And if we check continuity here, so you would expect, the power to be coming in through these inputs here and going through the shunt resistor and then out to one of these connectors. So if we probe on the positive terminal here, that's not connected to the shunt resistor, but the shunt resistor seems to be connected to the ground here. And I mean, it makes sense, because I think it's on the low side, so it's sensing on the low side, and you would have your current going through from here into the connector on the positive side. Yep. And then going through the battery, coming back out through the camera, going back out through the shunt resistor, and back into the supply on the negative side. So yeah, pretty straightforward. But it might be interesting to probe this metal terminal while the camera is running, so so we can see if there's any communication going on, or if it's just some basic analog signaling or what. I mean, I wouldn't be surprised if this were outputting just an analog voltage based on the current draw of the camera or something like that. But it kind of makes you wonder though. I mean, why have the current sense inside the battery? Why not do it inside the camera? I don't know. Could it be just extra protection in case the camera is broken, tries to draw way too much power from the battery? It's just it can just shut itself off. Well, no, I mean, so I don't know what the original batteries do, but this adapter board doesn't have any way of cutting off the supply voltage to the camera. So it would just be informing the camera about whatever the current is being drawn. So that's kind of odd. I mean, again, this is an aftermarket accessory. It's not an original Sony part. So there might be the original batteries might have a pass transistor in there to be able to switch off in case something bad happens, and they might also have a thermistor or some way to measure the internal temperature of the battery. This is not supposed to be managing a battery. It's just supposed to be a fake a dummy battery system. But I mean, I wouldn't be surprised if aftermarket clone batteries would use the same type of circuitry, because you can see over here there's there's footprints for a bunch of other components over here. Somewhere there might be a little battery management charger IC. I mean, this looks like it could be one of those. Look at these fat connections over here, right? So we're having these two fat traces going over here and over here, right? This might be either a switching element, to pass voltage based on. Yeah, that's actually what it is. Hang on, because look at this. So you got one side feeding into this chip, and then the other one goes into the shunt resistor over here. This board, I'm pretty sure it would be reused for non-original battery designs, and I do have an aftermarket battery that's starting to swell, and I don't really feel like using it. It wasn't that cheap, but it was cheaper than the original ones, and I said I'd give it a go, but it doesn't really perform that well anyway. So I might just tear that down, see if we find something similar in a battery. But anyway, let's try to solder some probing wires on these contacts. We're gonna go for the ground and the middle mystery contact, and try to put this in the camera and see if we can record anything on the scope. See if there's anything going on over there. Might be interesting to check if the camera will turn on if it can't communicate or can't read that third terminal, but I'm not sure I want to do that. I don't think I want to spend much more time on this. Alright, the board is getting away from me. There's one. No, it's not in focus. Alright. Let's do the other one. Oops. There we go. So we got our two wires hooked in, and we can reassemble this and try it out in the camera and check the oscilloscope. See if we can capture anything. Okay, so this is going to be some Inception type thing, because I'm using the I'm using the camera to film myself debugging the camera itself. So, well, let's just hook this up, see what we get. Alright, so ground hooked up, and then just clip onto the signal line. Oh, yes. There is something going on over there. Let's do a single shot. Okay. So there's definitely some communication between the battery and the camera. I mean, I'm not sure if this is what part of this would be a request from the camera and which part would be a reply from the battery, but it's probably something very similar to other one-wire protocols. Well, I mean, we don't know what data to expect in there, so trying to decode this would be, pretty difficult. I mean, at some point, maybe, yeah, there's a value for that current shunt being read, sent over there. Maybe, who knows, some serial numbers, some temperature reports, maybe. But there's really no way to know just by looking at it like this. I mean, we could probably extract individual bits out of this. Let's see. Let's check what the frequency is for this. So let's take a look at our smallest cycle here. Let's go cursor A. Move that over to the beginning of this pulse. Move cursor B over. It could be an 8 kHz clock in there. If this is one clock cycle, then yeah, you're communicating at sort of 8 kHz. But it's kind of weird, because if you look at some of these other, well, let's say, packets. See, for example, this one seems to be stretched out. It's not exactly 2, cycles. It's not 1, it's not 2, it's in between. So it's a stretched out pulse. So there might be more to this than just simply counting the up and down periods. But anyway, yeah, it's probably some proprietary Sony protocol. Maybe you can get some more info if you do some reverse engineering on the firmware on the camera. I know people have dumped the firmware on these cameras quite a few times, and some people even tried making little mods. Or was that the Nikon? I'm pretty sure every camera manufacturer has its little hacking community. But yeah, anyway, it's interesting. Yeah, hope you learned something.